Now my grandkids, or one of my grandsons, asked me how an air conditioning system works. And rather than just try and tell him, I thought I'd kind of put it in the form of a lecture and share it with some other people. But what an air conditioning system is, it's a heat pump. It's taking heat from inside the car or inside your house, taking it and putting it outside. And the way it does this, it uses a refrigerant. And a refrigerant is a material developed by DuPont, and it is in a liquid state and a gaseous state at saturation. If you take refrigerant and compress it with a compressor and get it high pressure, it will get very hot. And then if you take that refrigerant while it's hot, take it outside and cool it, blow 90-degree air across it, and it comes down to, I don't know, 120 degrees or whatever. And now you take that 120-degree refrigerant in the house, you run it through a little expansion, which is just a pinch valve, and you expand it down to a lower pressure. When it goes to the lower pressure, because of the nature of the refrigerant, it gets ice cold. So you take this high pressure gas, you've cooled it outside, you bring it inside, you expand it down to the lower pressure, and in that pipe where the refrigerant resides is ice cold. Now you take that pipe, chamber, wherever you put it, and you blow air across it, you blow 90-degree air across it, you'll get out 50, 60-degree air, cool, nice cool air. And then you take that refrigerant back outside, pump it up to a pressure, cool it, bring it inside, expand it down. So what you're doing, you're absorbing heat from the room or the car, and then you're taking that heat, and you're putting it outside. That's your condenser. That's the machine that sits outside your house, and you feel the hot air coming out. It has, say, 90-degree air going in, and then it's cooling that very hot refrigerant so that when it comes into the house, it will be at a very low temperature. So, if, like I said, if you think of an air conditioning system as a heat pump, taking the heat from one place and putting it to another, you use a material called a refrigerant, and if you put some refrigerant into a container, you get some liquid and some gas, and that's at saturation. If you take the gas and pump it up, here's our pump. If you pump it up to a high pressure, it gets very hot, and then we blow air across it, say 90-degree outside air across it, the temperature comes down. Then you run this part inside your house. It's pretty much liquid at this point because you've cooled it. You've taken heat out of the refrigerant, so it's pretty much liquid here. And we do have a separator that makes sure it's just liquid at this point, but that's minor. Then we put it through a pinch valve or an expansion valve or even capillary tube, something small where the refrigerant has a hard time getting through, and it gets through to a much lower pressure. And the minute it does, this becomes ice cold in here. And then we run that through a heat exchanger, run our warm air from our room or inside the car across it, and you get nice cold air coming out. Now, as you add heat to the refrigerant, it boils and turns all to gas, and then you run it back up into your pump, and that's the refrigeration cycle. Now, what is a heat exchanger? Here's a typical one. You have tubes, you have fins, very close. Here's a fin. They're just paper-thin aluminum, and then they're tightly fit to the tubes so that hot liquid here will make the tube hot, and the tube will make the fin hot. Then when the air blows across it, it'll cool the fin and heat the air. So you want to have a lot of fins and a lot of tubes, and you put hot or cold, whatever you do. Your car has a radiator. There, the hot engine coolant goes in. It runs down, and while it's running down these tubes, the temperature is transferring to the fins, and then you blow air across it, and that cools it. And then when it comes out, this is much cooler than it went in. Or if this is cold, then this becomes hot, whichever way. But heat exchangers are kind of basic. And that's what we have here. And what we have to do is take this part of the car or of the house, put it outside, and we all have that unit out back. You have a compressor, that's part of the unit out back. In a car, this is operated by the engine. And then you put, with this plumbing, you put this part inside the house, and that cools it, and then plumb it back to the compressor. Now what happens within the refrigerant, and I'll show this on a pH chart, pressure, and this is enthalpy, but it's really heat. So you add heat as you go in this direction, you add pressure as you go in this direction. So when this pump pumps the pressure up, it pumps it along this line from this pressure to this pressure. It pumps it up and it gets very hot. And then you remove the heat. This is the outside part. You remove it, and when you do, it starts, it's all gas here, and then it starts to turn to liquid here. And by the time it gets over here, it's all liquid. Then you take that liquid, and that's right here, and you expand it down to the lower pressure. That's here. And now you're at this low pressure, and this is ice cold refrigerant. You run that through your heat exchanger and into the pump, and it travels in that direction. And that's the basic refrigeration cycle. Now, what I'll do now is talk about how you would design something like this into a car. Now, if you had to put that system into a car, you have your windshield, your dash panel, your tow board, steering wheel, and the instrument panel typically is right there. Under that instrument panel, inside the car, the engineers have to find room to put a box, and the box is pretty big. And in that box, we have the evaporator, the heat exchanger that's going to cool the air. And we have a compressor operated by the engine. We have the fan to draw air across this is the radiator, that's cooling the engine. Then out in front of that, we put the condenser in, a heat exchanger that's going to reject the heat to the outside air. So then we plumb this from here. Those hot gases go into the condenser, heat exchanger, and then it comes out of here and goes into our evaporator, this heat exchanger that's going to cool the car. Now what's inside that box, and it's a fair-sized box. We have the heat exchanger put at an angle so that we can have a fan pushing air in, and this air can come from the outside or the inside depending on the control system. And I haven't covered the control system, but there's a lot of control systems that are part of an air conditioning system. And so the air is pushed in here, it goes through the coil, and that's that ice cold coil, and that cools the air, and then it comes into this chamber, and then we have different ways of getting it out of there and to the outlets that are on your instrument panel that you direct toward your face and you cool yourself. And the real estate, when you're designing some component within a car, you're fighting for real estate at all times. There's a lot of people that want to design stuff under that instrument panel, and you have to somehow convince them that your big box is more important than their radio or wiring or things like that. But and also when I haven't shown heat, but this same unit does heat. And the way we do that, we sneak another heat exchanger in downstream of the evaporator, then run engine coolant, hot water, through it, and that's what heats it. So in the wintertime, none of this runs. Your compressor doesn't run, but the hot water goes into another heat exchanger to heat things up. And then more controls, whether you want this discharge air on the floorboard, generally that's where we put it for heat, and then up at the AC outlets during the cooling cycle. And at this point, I'd like to make an editorial about the automatic temperature control systems that the engineers have designed in all the new cars. A lot of people, including my kids, want to operate the blower themselves and adjust the temperature themselves and all that. And I assure you, the engineers have gone into a great effort in coming up with a well-engineered system that will take care of everything for you. All you have to do is get in the car, start it, push, make sure that automatic button is pushed, and if it's hot outside, it'll cool you off. If it's cold, it'll warm you up. It won't start warming you up till the engine gets the coolant warm, and it won't turn the blower on high until the water gets hot. That's for the heating cycle. And so it knows how to keep you comfortable if you'll just let it do its job. You may have to make an adjustment. In the wintertime, you might want it 75 in the car, and in the summer, you might want it 70 degrees. But push that automatic button and just see what the engineers have designed for you, because they work good. And a lot of people don't use that, and they should. Well, I hope this clears up a few things. Thanks for watching.